Okay, so welcome back. Now we're going to do an example, a couple of examples where we're going to use the integral test to determine whether a series converges or diverges. So for the first one here in part A, we've got this series, and it's a series that has positive terms. Okay, so remember that it has to be, all the terms have to be positive. Now, what we're going to do is we're going to compare this to f of x equals 1 over x cubed. Now notice that this function is continuous, it is decreasing, and it does have the same values for all of the values of the integer n. So we know that f of n equals a sub n for all n greater than or equal to 1. Okay, so it meets the conditions. So now, what we're going to do is we're going to take the improper integral. So what we're going to do is we're going to say, okay, let's look at the improper integral from 1 to infinity of 1 over x cubed dx. Okay? So that means we're going to take the limit as t approaches infinity of the integral 1 to t of 1 over x cubed dx, which then is going to equal what? The limit as t approaches infinity of what? Well, now we're going to integrate this, and so we get negative 1 over x, 2x squared, and we're going to evaluate this from 1 to t. And now, this is going to equal the limit as t approaches infinity of what? Now this is going to become negative 1 over 2t squared minus 1 over 2 times 1 squared, right? Well, what does this become? This is just 1. So 1 times 2 is just 2. So this is going to become 1/2. And so what happens? As t approaches infinity, this is just going to go to 0. So then I get what? Negative of a negative 1/2, which is just going to give me 1/2. So therefore, the improper integral converges. It converges to 1/2. So therefore, the series 1 over n cubed also converges. Now again, remember, it doesn't necessarily converge to 1/2. Okay? The theorem doesn't tell us that. Okay, now let's do the other one. So now we've got this one. Okay? So now, we're going to compare this one. Oh, first of all, again, this is a series, an infinite series with positive terms. All the terms are positive, starting with n equals 1, right? So we got positive terms. And we're going to compare this then to f of x equal to 1 over the square root of 2x minus 1. So now, notice that this is a continuous function. It is a decreasing function. And for all values of n, f of n equals a sub n. So again, it meets all the criteria. So now we can do the integral test. And so what we're going to do is we're going to take the the improper integral. So we're going to go from 1 to infinity of 1 over the square root of 2x minus 1 dx. Okay? And so now in this case here, we're going to do U substitution. But in fact, I'm going to do a limit. So I'm going to take the limit as t approaches infinity of the integral from 1 to t of 1 over the square root of 2x minus 1 dx. Okay, so now I'm going to integrate, but I'm going to use the U substitution. So I'm going to say that u equals 2x minus 1, du equals 2 dx. So that means I'm going to take 1/2 du equals dx. And so I'm going to say, and so when x is 1, yeah, so when x is 1, u is 1. Okay, so that'll work. And then when u is t, or excuse me, when x is t, this will be 2t minus 1. You know what? Instead of changing the integral, I'm just going to change it back when I'm done. So let's just continue on. I'm not going to change the limits of integration because I'll just change it back to 2x and we'll go from there. So no big deal here. So now what do I get? Now I'm going to integrate. So this is, or I'm going to use my U substitution. So I'm going to just leave this as 1 to t. Oops, hold on. I dropped my limit. So this is going to be the limit as t approaches infinity of the integral from 1 to t. And this is going to be what? It's going to be 1/2. So I'm going to 1/2 1 over u du. So 1 over the square root of u du. Okay, so now I'm going to integrate that. Well, if I integrate that, that's now going to become the limit as t approaches infinity of, that's going to be 1/2 times, well, if I integrate this, this becomes u to the 1/2 times 2, because you have to divide by the reciprocal. You have to divide by the new power. And so that's going to become times 2. So this is going to end up being 2 over 2. Right? So this is going to end up being just the square root of u from 1 to t. So now I'm going to change everything back to x. So now it's going to become the limit as t approaches infinity of what? The square root of 2x minus 1. So 2x minus 1 from 1 to t. Okay, now this becomes the limit as t approaches infinity of what? It's going to be the square root of 2x, sorry, not x, 2t minus 1, okay, minus the same thing evaluated 1, which is going to be 2 minus 1, which is 1, and the square root of 1 is 1. So that's what we get. Okay, so now here's the thing. What happens to this as t goes to infinity? Well, this thing goes to infinity, so the whole thing goes to infinity, and therefore the improper integral diverges, and hence, if this diverges, the original series also diverges, and we're done. And that's it. See you next time.